I'm Miroslav Bajtoš from the Filecoin Station team, and today I would like to convince you that the next time you run an experiment similar to Puncher, use Station to run it. Does anybody remember Puncher? Yeah, it was a pretty cool thing. They were trying to measure effectivity of hole punching from different networks because different routers networks behave differently. And as part of this experiment, they had to build a small desktop application running in the background and trying to punch holes in your net. And it's quite a lot of work to pull this off, if you think about it. First, you need to build binaries for all different operating systems and architectures, but that's just the first step. Then you need to code sign it on Apple for Mac OS, and to do so, you need to apply for the Apple Developer Program, get your certificate, set it up. It's quite a lot of work. You also need to notarize your binaries to be able for users to install them on their computers outside of the App Store. You also need to code sign it for Windows because they have code signing, right? Okay, now we have the tool. People can install, but that's not enough because you don't have any people running it. So you need to start writing blog posts, messages in the forums, but that's not enough because people don't read nowadays. So you need to get on the stage and give a talk, but one talk is not enough, so you need another talk. And then eventually you have a network of hundreds, maybe thousands of nodes that can perform the measurement for you. So much yak shaving. All right. And so the idea is that we are building Filecoin Station to help you with this, among other things. And our proposal is we handle the boring parts you don't want to even know about, and you just focus on building your probes. That's the idea. And now I would like to walk you through what it means and how would it work. At the very high level, we have a station node which contains some low-level parts like runtime. It can run on desktops, on servers, and it's running different modules, multiple modules. You can think of a space station which have a habitat module and a scientific lab module and other modules. One of these modules could be your probe that's testing libp2p networks, and you just write your probe. Then you will need your backend, which is ingesting data from the measurements, but that's something you need to run anyways if you're running an experiment like this. And then the final piece is the Meridian platform, which is taking care of rewarding operators for running your probe, for contributing their network resources, their computer resources, and just helping out. And to make this work, you need to write an evaluation function, which will evaluate the impact of each node performed, so that we can pay out the rewards. And then when it comes to implementation, you can write your probe in a JavaScript right now, but in the future in WebAssembly as well. And when I was writing a simple ping probe, we were just trying to test whether libp2p bootstrap nodes can be reached from different parts, from different networks. It was less than 99 lines of JavaScript code, pretty easy. In essence, you have a long-running process which does the testing. So it's up to you to decide what should it do. You can run a loop. Every now and then you pick a random peer, then you ping the peer, that's the probe part, and then you record what you measured, sleep a bit at the end before you do the next try, and that's it. That's the whole probe, essentially. Then the second part, which I was showing on the diagram, architectural diagram, is rewarding people for running your probe. We are building an impact evaluator based on the impact evaluator framework idea. And this idea is pretty simple. You run 3 steps. The first one, you measure what happened in the world out there. Then you evaluate impact of every participant. And finally, you reward this impact. And there are different ways how you can calculate or evaluate the impact. The easiest one is you sum all the measurements performed by the network, and you assign the fraction of measurements made by you as the final score. So if the network performed 100 measurements and my node performed 5 of them, then I will get 5% of the reward from the pool for the given round. And then, so that's the second step. In the middle, the first one, you want to do some fraud detection. So if people are doing more jobs than they are supposed to or doing other things which they are not supposed to, you want to discard those measurements. Second, you calculate the scores, and the last step is just to submit the scores to the smart contract running on chain, and the smart contract will take care of the rest. It will distribute rewards to users. And then finally, you just deploy to Filecoin Station. It's these 2 oops, sorry. These two lines at the end, module name, so that we can identify it in our logs, and then IPNS key. We are using IPNS together with IPFS to distribute new versions of your source code, of your module. In the past, or in the initial version, we were using GitHub releases, which was super easy to get started with, but it turns out GitHub is not accessible, I think, in China. So people were complaining they are not able to upgrade, so we switched to IPNS, which works pretty well. The idea is you publish your module to IPFS, you get a CID, and then you update your IPNS record to point to the new version, and that's all you need to do. We have even GitHub Actions to automate this for you. And then Filecoin Stations will pick up the new version and run it for you. So what is it, Filecoin Station, you might ask? It's a desktop application. It's designed to be very invisible to users. So by default, it starts in a tray, just a small icon. And you can get more details about the app. We are measuring number of jobs your node completed, your rewards. It's growing slowly, but the more modules we have, the faster it will grow. The application also comes with a built-in Filecoin wallet, so you can receive the rewards and then transfer them out if you like. And right now we have, I think, like 20,000 nodes running all around the world. The more interesting part is that we have 2,000 desktop instances, which probably correlates to 2,000 people running one instance on their computer. We have 1.7 thousand unique IPv4 subnets. So we are really running in very different networks all around the world. And this is all available for you to run your libp2p probes if you are interested in doing so. So to quickly recap, you write your probe, you write the impact evaluation function, so we know how to reward people for running your probe. You need to secure some funding to pay the operators. You add the probe to the station, and it's there, running all around the world. Thank you for the attention. You can talk to us on the Filecoin Slack. You can find us on Twitter. And if you scan the QR code, it leads to our website where you can download the application from, and you can run it yourself.